Hi everyone, I am going to discuss about photomultiplier tube. The components of photomultiplier tube are uh, glass vacuum tube, photocathode, several diodes, one anodes. And this is the pictures of photomultiplier tube. It consists of incoming photon, photocathode, window, diodes, anodes, and focusing electrodes, and a power supply. Then how it works? Electron is released by photocathode. Electron is then multiplied by the electrodes or metal channel diodes. At the end of the chain is the collection of electrodes, that is anode. The current flowing from the anode to ground is directly proportional to photoelectron flux generated by the cathode, photocathode. Photocathode. Photocathode is usually an opaque or semi-transparent layer of photoemissive material such as CS3Sb. It is an intermetallic compound of cesium and antimony. When the photon from a scintillation medium impinges on a photocathode, a fraction of this photon is absorbed, resulting in the emission of photoelectron from photoemissive material. Then quantum efficiency of photocathode. The ratio of number of photoelectron produced to the number of incident photon is defined as quantum efficiency of photocathode. Common photocathode exhibit quantum efficiency up to 20 to 30%. As expected, the quantum efficiency of photocathode depends on photocathode material and wavelength of scintillation light. Then it becomes zero above a threshold wavelength when the energy imparted to an electron is not sufficient for it to escape from the photocathode surface. There is also a short wavelength cutoff which is determined by the transparency of glass or quartz window through which the scintillation light has to enter to reach the photoemissive layer in the photomultiplier. For normal gas, this cutoff occurs at wavelength in the region of 350 nanometer. For the best result in the scintillation spectrometry, the spectral response of the photomultiplier should match the spectrum of the scintillation light. As considerable variation of the response exists among different make of photomultiplier tube, it is necessary to careful to choose the photomultiplier that is best suited for a given scintillation detector medium. Another characteristic of a photomultiplier which need to be considered in its use with a scintillation detector is the thermionic emission of electron from its photocathode. As this result, photomultiplier dark current, it contributes to noise in the output of the scintillation detector. Since material with have higher quantum efficiency and also have a large thermionic emission, photomultiplier which have higher photosensity also have a large dark current. The dark current can, however, be reduced by cooling the photocathode, as it's sometimes done in special application requiring very large signal to noise ratio. The function of multiplier portion of the photomultiplier tube is based on the process of secondary electron emission. When an energetic electron strikes an electron emissive surface, the secondary electrons are emitted from the surface by a process very similar to photoemission method. For suitable chosen surface, the secondary emission coefficient is defined as the number of secondary electron emitted per incident electron become much greater than unity. This offers the possibility of a cascade amplification. The electron multiplier portion of a photomultiplier tube therefore consists of a series of secondary emissive surfaces called diodes. The photomultiplier is operated by applying progressively increasing the positive potential to them. In the first stage, the lower energy electron leaving the photocathode are accelerated towards the first diode. At dynode, each incident electron produces secondary electrons of lower energy. In the next stage, the electrons are accelerated from their point of origin to next dynode to produce a number of fresh secondaries for each electron. Thus, in subsequent stage also, multiplication process continue down the dynode chain to the finally resulting large electron multiplication. The spread in transit time arises due to difference in the electron path and in the electron velocity. These spread contribute to rise time and the time jitter in the output pulse and need to minimize in experiment involving the time measurement of incident radiation. The transmit time spread is much smaller in photomultiplier tube which has higher gain in only in few dynode states. Thank you.